All right, let's do a quick review of the activities for week 8. Students are going to have to do a quick spreadsheet setup in class, create a RoboLab program, and then arrange the RCX to power a simple light bulb circuit. Another video will talk about the experiments that you're going to do with that equipment. But let's take a quick look at the spreadsheet setup. So you'll be checking the performance of the RCX outputs feeding a light bulb at different power levels. And so this upper portion of the spreadsheet allows you to enter the voltage output and current that you'll be measuring with the light bulb circuit. Say you're going to be having about 9 volts, and it might pull 60 milliamps. And so this would calculate the power automatically. So you need to arrange your spreadsheet to do these calculations as well. And you'll do these tests at each different power level. It'll take you just a few minutes. Separately, the instructor will view for the whole class what the waveforms coming out of the RCX look like based on duty cycle and frequency. And so you might put in, make observations of a 250 hertz signal operating at 12.5% duty cycle, and the peak voltage might be 8.8 volts. And so with that in mind, your highlighted cells here will calculate the period from the frequency and then determine the average voltage based on the analysis of the duty cycle and the peak-to-peak voltage. You can expect that the average voltage seen here might end up matching the voltage seen when you're taking your measurements with the RCX, or of the circuit powered by the RCX. So it might actually be the 1.1 volts there. So this is stuff you'll be verifying in class, so that's what this upper portion is. Subsequently, these two other sections ask you to change the power level again. You'll arrange the circuit to drive one of the Lego motors that we used on the robots. The first section will be measuring voltage and current levels. Here as well, again putting in 5 volts and 0.01 amps and figuring out the power drawn by that motor. The first data here is with the motor running free, no load on it. The second one would be with some resistance, and that will be in the form of students holding the motor and preventing it from rotating. So it might be 9 volts and the current might be 0.2 amps, and so the power settings would be different. So you'll do this at each of the power levels here to gather a little data about how much energy the RCX can provide when it's being loaded down. So but to do this, you'll need to power the RCX. And so let's take a quick look at what program would be quickest to make. We've got, we'll power a motor for just a few seconds here. So we'll add motor A. Go ahead and power it for 10 seconds. That's enough time to take a good voltage and current reading off your meters. And then we'll use the stop command on A. Of course, we'll wire this in. In this program, the default motor setting like this would be a power level of 5, and so we're going to want to vary that, so we'll use the modifiers. And what we'll do is we'll bring in the power level of 5, and it would normally be there, but since we're going to modify this each time, we'll bring in each of the different power levels. There's another way to do this, but for now this will work. And power level 1. So if you have this available, then you can power motor A at power level 1 and use this type of a program. So for each one of your trials, you can modify the power level applied to the motor. I believe it will work with the other power levels sitting here, even though they're not attached, but you'll have to verify that. Another option would be to do a right-click, replace the modifier with the power level that you want to use, say 5 for example. So that allows us to replace this modifier each time and then reprogram the robot. So coming back to this, so that gets us the spreadsheet set up in the RoboLab program. A separate video will show you how to set up the simple circuit and complete the 2 experiments.